So in this video, I'm going to talk about this haloalkanes and haloarenes. So let's look at what are these haloalkanes and haloarenes before looking at the classification of these. Yes, the first thing, what is a haloalkane? So the haloalkanes, as the name, this one, the hydrogen of this aliphatic compound has been replaced by this halogen, then it is called as haloalkanes, where the H of this methane is replaced by this halogen, where the X can be fluorine, chlorine, bromine, or iodine. Any halogen is replaced by this halogen, then it is called as haloalkanes and haloarenes. When the hydrogen of this aromatic ring is replaced by this halogen, then it is called as haloarenes. So the presence of double and single bonds alternatively, or the pi electrons in this ring are in conjugation, then it is called as an aromatic ring. So when the hydrogen of these hydrocarbons, when it is replaced by halogen in the aliphatic compounds, then it is called as haloalkanes. When in the aromatic ring, then it is called as haloarenes. So now look at the classification of this based on the number of the classification of this based on number of halogens. Yes, based on the number of the halogens, these haloalkanes can be classified as monohaloalkanes, where there is a single halogen which is present on this aliphatic chain, or dihaloalkanes, where there are two halogens which are present, then it is called as dihaloalkane, or trihaloalkanes, where there are three halogens which are present in this. So they are called as monohaloalkanes, dihaloalkanes, or trihaloalkanes based on the number of the halogen atoms which are present in them. And these haloarenes also classified as monohaloarenes, where is the single halogen on this aromatic ring, or dihaloarenes when there are two halogens which are present on this aromatic ring, or trihaloarenes when there are three halogens which are present on this aromatic ring. So depending upon the number of the halogens which are present on this ring, then they are classified as monohaloarenes, dihaloarenes, or trihaloarenes, and these halogens can be present at any positions on this ring. Yes, this is a classification which is based on the number of the halogen atoms. Now, these monohalo derivatives can be further classified depending upon the carbon atom to which this halogen is attached, whether it is sp3 hybridized or whether it is sp2 hybridized. So if the halogen atom which is present to, this is based on the nature of the carbon atom. Yes, I'll write here based on the nature of the carbon atom to which this nature of carbon atom to which this halogen is attached, they are classified as, if the halogen is attached to a sp3 hybridized carbon atom, then there can be again three classes in this: alkyl halides, that is the compounds containing sp3 hybridized carbon atom attached to this halogen. They have CsP3X bond here. Yes, alkyl halides or haloalkanes. And next one is allyl halides. And the third one is we have here benzylic halides. Yes, this is the halogen is attached to the carbon which is sp3 hybridized. And if the halogen is attached to an sp2 hybridized carbon atom, they can be again classified as vinyl halides and aryl halides. Yes. Depending upon the nature of the carbon atom to which this halogen is attached, there can be there can be CsP3X bond or CsP2X bond. In this class, they can be either alkyl halides, allyl halides, or benzylic halides. And in this class, where carbon is sp2 hybridized, they can be vinyl halides or aryl halides. Let's look at each of them in detail now. Yes, when we look at the class of this alkyl halides, the first one is alkyl halides, where the carbon is sp3 hybridized here. So let's remember this. C is sp3 hybridized, where this halogen is attached. So simply, these are also called as haloalkanes. They can be designated as R, X. And the general molecular formula of this homologous series is TCN H2N plus NX. Yes, first one is in the in this we have R CH2X, where this halogen is attached to this sp3 hybridized carbon atom. So it is comes under this class of compounds where this carbon is primary carbon. This is a primary carbon because it is attached to only one other carbon atom. So this carbon is a primary carbon. So this is a primary alkyl halide. So this is right here primary alkyl halide. And the second one, I'm taking the second example here. So this is halogen is attached to the carbon, which is secondary in this case, and it is sp3 hybridized. So a carbon which is attached to two other carbon atoms is a secondary carbon. So the name secondary alkyl halides. Okay. And we have tertiary alkyl halides where the carbon is attached to three other carbon atoms. So it is tertiary. This is tertiary in this case. So these are tertiary alkyl halides. So again, three classes in this: the primary alkyl halides, secondary alkyl halides, and tertiary alkyl halides, depending upon the nature of the carbon atom. It is sp3 hybridized, but whether it's primary, secondary, or tertiary, there can be primary alkyl halides, secondary alkyl halides, or tertiary alkyl halides. Then the second class is under sp3 hybridized carbon atom is allyl halides. This also is CsP3 hybridized X bond. So let's recognize what is this allyl carbon before. Yes. This carbon which is attached to this carbon. This carbon which is attached to a double bonded carbon is called as allylic carbon. So the carbon which is attached to a C double bond C system. So the halogen in this case attached to a carbon which in turn is attached to an C double bond C system. So this carbon will be, no doubt it is sp3 hybridized, but this is attached to a C double bond C system. Such carbons are called as allylic carbon. So here the halogen is attached to the sp3 hybridized carbon atom, but which is attached to a double bond, C double bond C. Such carbons are called as allylic carbon. So yeah, these are primary allyl halides, because here the halogen atom is attached to an sp3 hybridized carbon atom which is primary, and this is attached to a C double bond C. So these are the compounds in which the halogen atom is bonded to an sp3 hybridized carbon next to C double bond C. And if this halogen is attached to a sp3 hybridized carbon atom but to a secondary carbon, then these are called as, this is an allylic carbon in this case, because this carbon is attached to a C double bond C and this is sp3 hybridized. These are secondary allyl halides. Yes. Now, if this is attached to a carbon which is tertiary, this is tertiary, right? So allylic carbon and tertiary and sp3 hybridized. So these are tertiary allyl halides. Yes. So these allyl halides can be primary, secondary, and tertiary. Next, coming to the third class of compounds, that is benzylic halides. Yes. So let's understand what is this. The carbon is again sp3 hybridized. So it is C sp3 X bond. This is called as a benzyl group. First of all, let's look at this benzyl group. Here, the halogen is attached to a carbon which is sp3 hybridized, which is next to that of an aromatic ring. So this carbon which is attached to an aromatic ring is called as benzylic carbon. Directly attached to the aromatic ring is called as benzylic carbon, and the halogen in this case is attached to this benzylic carbon or called as primary benzylic halides. Benzyl halides, yes. And if this carbon, the benzylic carbon is secondary, it is sp3 hybridized and benzylic, but this is secondary because it is attached to two other carbon atoms. Here carbon, then it is called as, this is secondary carbon in this case. So they are called as secondary benzyl halides. And if it is attached to tertiary carbon, but still sp3 hybridized, these are attached to three carbons, right? 1, 2, 3, this carbon. This is tertiary. So these are called as tertiary benzyl halides. So in CsP3X hybridization, I mean the bond which is, let's look at it once again. See, based on the nature of the carbon atom to which this halogen is attached, whether if it is sp3 hybridized, there can be alkyl halides, allyl halides or benzylic halides. In alkyl halides, again, in all these classes of compounds, we have primary, secondary, and tertiary, depending upon the nature of the carbon atom to which this halogen is attached, whether it is primary, secondary, or tertiary. But in all these three cases, it is sp3 hybridized. Now, look at the classification now. Now for the aryl halides. Yes. I mean the carbon atom, if it is sp2 hybridized and attached to the halogen atom. Let's look at the classification of this type of compounds where there can be vinyl halides, or I said there are two types, right? Or other one is aryl halides. It's very simple. Those vinyl halides are nothing but the halogen atoms in which the halogen atom is bonded to an sp3 hybridized carbon atom of a C double bond C. So C double bond C with the halogen atom is attached to a C double bond C. This such type of compounds in which the halogen is attached to an sp2 hybridized carbon atom of a C double bond C, they are called as vinyl halides. So this is the simplest vinyl halide. And other example for this is a vinyl halide. Okay, this is also vinyl group. So here the halogen is attached to sp2 hybridized carbon atom. This is sp2 hybridized, right? So such are called as vinyl halides. And aryl halides, where these are the compounds in which the halogen atom is attached directly to an aromatic ring. That is, it is sp2 hybridized and is aromatic. So in which the halogen atom is bonded to sp2 hybridized carbon atom of an aromatic ring. These are called as aryl halides. Okay, other example for this aryl halides is just a toluene. This is toluene, and on this aromatic ring you can place halogen on any of these positions, then it will be a aryl halide. So this is a classification of haloalkanes and haloarenes based on the number of the carbon atoms and based on the hybridization of the carbon atom to which this halogen is attached. So again, for dihalo derivatives, there is another type of classification. Let's look at it. Yes. If the halogen atom is attached to the same carbon atom, these are called as gem dihalides, because these are the halogen atom, that is the same type of halogen atom, here in this case chlorine, is attached to the same carbon atom, then they are called as gem dihalides. And if it is present on the adjacent carbon atoms, then they are called as vicinal dihalides. These are present on the adjacent carbon atoms, they are called as vicinal dihalides. If it is present on the same carbon atom, then they are called as geminal dihalides. Yes, this is a classification, and the common name for this gem dihalide, that is CH3CH2, is ethylidene, because it is obtained by the addition reaction of ethylene. So the common name is derived from there is ethylidene chloride. Yes, this is ethylidene chloride, and this is 1,1-dichloroethane. Yes, the IUPAC name is 1,1-dichloroethane. And the common name for this is ethylene dichloride. Yes, ethylene dichloride. And the IUPAC name for this is 1,2-dichloroethane. Yes, dichloroethane. So this is alkylidene chloride commonly, and this is alkaline dichloride. So this is the classification of this dihalo derivatives. That's the gem dihalides, where the halogen atom, there's the same type of halogen atom is present on the same carbon atom. And if they are present on the adjacent carbon atom, they are called as vicinal dihalides. So this is the classification of haloalkanes and haloarenes.